Hey class, I wanted to make a help video here for this Wiley Plus homework problem. This is a fun one. Robin Hood is fighting here, doing a sword fight with these three different guards, and he's trying to get away. And so what he decides to do is grab onto a rope that's holding up a chandelier, cut the rope, and hopefully, as it looks like the masses would confirm that the chandelier weighs more than him, so he would accelerate upward after cutting the rope as the chandelier then accelerates downward. And so in this case then we need to try to figure out what that acceleration upward is for Robin and also the tension in the rope as that occurs. So this is a little bit tricky, but we're trying to figure out Robin's acceleration. We got forces going on, so we should automatically think in the process. Let's do free body diagram and try to set up some of the forces. The nice thing here, actually, all the forces are just in the vertical direction, so we don't even have any x forces at all. So we're going to look at Robin here. We're going to do a free body diagram for him. So that's Robin, all right. And we're going to have the tension in the rope pulling him upward. We're going to have his weight going down, so the mass of Robin times gravity. And we know that he will accelerate upward as he escapes. So when we go to do some of the forces in the vertical direction, since there's no forces in the horizontal direction, we know they're going to equal mass multiplied by acceleration. And in this case, we have tension in the positive direction minus Robin's mass times gravity in the negative direction, and that's going to equal mass of Robin times his acceleration, which is positive. It's up, so I leave it as a positive value there. Which sounds good, but the problem is in order to find A, we need to know T, or to find T, we need to know A, and we don't know either, so at first glance it looks like we're stuck. But what we're going to have to do then is look not just at Robin, but then look at the chandelier as well. So let's now try the same process with the chandelier. And the reason that I am choosing to now look at the chandelier is I know that it's, one, attached to Robin, and two, it's accelerating at the same rate since it's tied to Robin. The only difference is its acceleration is in the downward direction. So let's make sure we note that it's accelerating down at the same rate that Robin's accelerating up. So again, these two accelerations here and here represent the same overall net acceleration. If we look at the free body diagram for the chandelier, it's going to have the same tension force pulling it up, same rope, so it's the same tension, and its weight, which is the mass of the chandelier, times gravity, pulling it down. So if we go to do the sum of the forces in the vertical direction equals ma for the chandelier, we're going to have T going up minus mg going down equals m times negative a for the chandelier since it's accelerating in the downward direction. Now we have two equations with the same two unknowns. So we can see we can solve this equation for tension, observing that it's going to be equal to the mass of the chandelier times gravity minus the mass of the chandelier times acceleration. And now we can take that and plug it in up here to Robin's equation, since T equals T, replacing T with mass of the chandelier times gravity minus the mass of the chandelier times A, that's all just T, minus the mass of Robin times gravity equals the mass of Robin times A. So you're using the same idea, the same process, applying it to two objects and substituting them together to solve. And so now let's go ahead and try to solve this equation for acceleration. Since we know the masses and we know G, we should be able to do algebra to solve for A. Once you have A, you plug it back in down here and you get the tension because you already have an equation set up for it. So try that out and let me know if you have any questions. Have a box-worthy day.